started, just a quick recap. What did we do yesterday? We started to talk about graphically arranging or representing data. Line plots we've already covered. So I don't know if you just want to have a, units, right? And then you just put a whole bunch of points all over the place, right? Frequency table, that's when you have 3 columns, right? That's what a frequency. So what we're doing with a frequency table is we're gathering all the data points into one table. And we have interval, tally, and frequency. Hence, frequency table. Right? So this is on page 8 in case you're wondering. Histogram, it's basically just a bar graph, right? And it will be different, right? It differs depending on what the data is telling us, right? So that is a histogram. And what's a frequency polygon? It's basically, let's make our bar graph. I'll just make another one here. Like that. And so basically what you're connecting is the midpoints of those bar graphs, right? So we kind of just put, you don't need to have a bar graph before you do frequency polygons. It's possible to do without a bar graph, but I find that it's so much easier to just draw your histogram and then plot the frequency polygon. Quite often I do them both at the same time. Okay, so 4 ways of graphically organizing, and you're like, Mr. Dirksen, the frequency table isn't really a graphic. It's not a graph, but it is still, it does show you a little bit after, because imagine thousands, tens of thousands, hundreds of thousands of data points. Can you imagine that? That's what most statisticians, that's what they deal with thousands, hundreds of thousands of data points. Like, can you imagine the World Health Organization? They get data from all these countries. So now we're looking at billions of data points, right? So we need to gather it, and then we can have graphs that show us a bit more. Okay, we learned about frequency tables, right? So there it is. That's kind of what goes with a frequency table. And I told you that the midpoint column here, I just inserted that because quite often you will need it for your frequency polygon. These are the midpoints, right? This is the point in between that histogram, the bar. It's essentially 112.5, right? Between these two, this is the interval. And so we came up with that. Today, we're going to actually go a step back and we're going to create a frequency table from scratch. Okay? Can I just ask you to add something on page 9? I told you the frequency polygon is the red line, right? Histogram would be just the bars. But the dots, those dots here represent the midpoints. Those are actually the midpoints that we are connecting. So I want you to add that there. And now I'm going to give you a very, very short version of what we just did between yesterday and today. Okay, so basically data, right? So we have what we call data. We put that into a frequency table. And that's this one, right? Interval, tally, frequency. You will realize that the tally column will sometimes not be there. And I will explain why. And then you have two options. Do you want to go histogram or frequency polygon? To be honest, if I had a choice, I would always go histogram. It's so much easier. You don't have to find the midpoints. It's just make your bars and then you're good to go. But that's what we're going to be doing. We're going to get a bunch of numbers, sometimes even 50. Oh my goodness, right? 50 values, and that's actually small and compared to real life, right? Then frequency table, we're going to put that into our frequency table, and then we're going to choose how we're going to actually graph this thing, okay? That's what we're going to focus on today. It's going to be work. It's going to be tedious, but you need to be good at it. And you can take forever to do that, okay? So it's the speed in which you do it that we're going to focus on today. So go with me to page 10. We're going to go from scratch. And I actually had more points at the beginning, but I just decided to shorten it a little bit. Ready? The following data represents the flow rates of the Red River measured at the Redwood Bridge between 1972 and 2001. It's measured in cubic meters per second. I actually like that the units are kind of weird, but it's just saying how many cubic meters of water per second. Okay, so if you're wondering what kind of units are we dealing with, we're dealing with that. Okay, it's actually a rate. Okay, so I'm going to guide you through it, but I don't necessarily have to tell you that, but it says calculate the MCTs, standard deviation, and the range. Let's go and do that right now. So enter this into your L1, right? Enter that into L1, and then we're going to figure out this. So I'm going to find my mean, my median, mode if there is one. We're going to figure out our standard deviation, and we're going to figure out the range. And while you're clicking away, I think I already entered this. Did I do that? Yeah, I did. I did do my homework, and I entered that already. So you go ahead and do the same. And go ahead and find the MCTs and the standard deviation. Feel free to do that. I'm already doing the attendance for Friday. Never mind. Start again. Okay, good. I don't know where you're at, but I'm going to run my calculations here. Maybe a fun fact, if you don't feed one variable stats anything, by default, it's going to take L1. But I just like to always make sure I remember to feed it something. And so I get 1,551.77, and I need to put some units on there. Cubic meters per second. My standard deviation, I can write that down, is 951.49. That's right here. Okay. 49 cubic meters per second. Yeah.
Are we not supposed to round anything from there? Like, didn't you state that we're not supposed to round, say, the
Right. So
1.551?
two decimals is fine.
2 decimals is fine?
Yes. Yeah. What I meant was like don't round it to a whole number. For example, when we're talking cases like people and stuff like that, a lot of students want to round it. Don't round it because we use it to measure, to compare data sets. So it's okay. My median is 1507.5 cubic meters per second. And the mode, I'm going to wait for a bit. I'm going to figure out my range. And I don't have a lot of room. So I think I'm going to just do that up here. 4587 minus 159. Okay. And you can actually look at your numbers and just calculate it right under. Right. I'm just doing that right there. So that's 4,428 cubic meters per second. The range is not an MCT. Okay, range is not a measure of central tendency, and nor is the standard deviation. Right, so I don't know, I feel like it's crowded already, but I'm just gonna kind of box this in. These are my MCTs, right? Measures of central tendency. And I need to figure out my mode. Remember, this calculator is very powerful, right? It can help you. I'm going to sort my list, and then I'm going to go check for modes. If there is one. Anybody check already? I actually did not check for mode. I'm not seeing any repetitions so far. No mode. No mode. Okay. NA. I'm just going to go NA like that. Not applicable. That's fine. And then the range is right there. So if you probably know enough about the Red River that the levels change dramatically within days. So the range is pretty big, and you would probably expect that compared to rivers further down south, the Red River is going to be pretty bad in terms of fluctuations, in terms of how widespread data is. Some years it's dry, no problem. Some years, like this year, we got hit with 3 Colorado lows back to back, right? It's not looking too good. So now the second step is we're going to create a frequency table using 9 to 10 intervals. So I'm giving you a little bit of a hint. I don't want it to be wide open. If you go back to the original, I said anywhere between 5 to 12 or something like that, or I will give you hints on a test. I will not leave it wide open. Okay, so you don't have to worry about that too much. So what I do, right, what I do before I come up with this is, for B here, is to determine the width. Determine interval width. Okay. So you basically are saying how wide are my bars going to be. And what I do is I go range divided by intervals. Range divided by intervals. If you can't read that, it's intervals. Okay. Number of intervals, I should say. What is my range right now? It's 4,428. And you know what? I'm going to use 10 intervals. Hold it. Why 10, Mr. Dirksen? Because I already printed this table. So watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows, right? So I have room for 10 intervals. I will do that for you as well on a test. So you're going to be like, oh, okay, this is how many slots I have. So let's divide that. You get 442.8. And this is the bizarre part. So 442, that would be a weird increment. That would be a weird width to have. So pick something that is nice and round. So I will say approximately, you could go 450 if you'd like to, but I'm going to go 500. That gave me a bit of an idea. I'm going to go with a width of 500. It's so much easier to work with. Okay. So I'm actually going to highlight that so you know that's my interval width. Okay. Interval width is 500 in this case. Somebody's asking, Mr. Dirksen, if I went with 400, could I have gone with 400? Yeah, you could have. It would have worked, but you might have had a bit of an issue having enough intervals here. I would always round up, to be honest. So 450 would have been okay. I'm picking 500. I just want to make sure you understand that it is somewhat arbitrary. So interval, what do I mean by that? You need to go low enough. Watch this. My lowest value is 159. So I'm actually going to go from 0 to 500 cubic meters per second. That's going to be my first bracket where I'm going to enter data into. And then you just go up by 500 every time. 1,000 to 1,500. 1,500 to 2,000. And so forth. You just keep on going up by 500 every time. Do you see now why you would want to pick a nice round number? It's easier to come up with your intervals, no calculator needed. Sometimes 100 will be good, sometimes 50, sometimes 3. It depends on what your situation is. What are you trying to organize? Oh, sorry. You got to go right. I went from here to 3,000, so I got to go 3,000 to 3,500. 3,500 to 4,000. And what's my largest value I need to account for? I'm going up here to my, right up here. I need to have, like, this number needs to fit in. So if I stopped it there, I'd be in trouble. So I need to go one more. So that's the start of my frequency table. I just want to say this. You got to make sure, let's say, for instance, and it's in the notes, let's say you have a value of 4,000 exactly. You're like, well, there's a 4,000 there, there's a 4,000 there. Where would I put the value in? Always the lower bracket. Always in the lower. This is the higher bracket, this is the lower. So if there's a value that ever falls in between, always pick the lower, okay? It happens from time to time. So let's go through our sorted list. I'm going to do this. I'm going to turn on my calculator. And if it's sorted, it's so much easier to put this in because you're not going all over the place, right? So I'm going to have this here. And so 159 goes in there. 187, right? 280, 396. Oh, there's 500 exactly. So where would you put that? In this one, and the lower one, not in the upper. So 500 counts here. 564 is already here. 881, 946, 991, 1,048. So I already go into my next bracket. 1121, 30, 1390, 1393, 1399. So when you have 4, you make a 5th entry by doing this. So we know that that represents 5 entries. 1458, 1557, 1589, 1671, 1750, 1785, 1807, 1812, 1877, 2080, that bumps me to the next one, 2081, and so forth. You get the picture, right? 27, that gets me there. 3030 gets me in here. 3058, 4587. 4587 is right here. So you're like, we skipped 2. No, you didn't skip 2. There's just nothing that fits these 2 intervals. There's just nothing there. Okay. But you need to go up by a consistent interval. That is very important because these are the width of your bar graph. Remember that. Okay. So now the tally is where you actually count them individually and then you just bring it all together. This will be 5, 4, 6, 8, 3, 1, 2, 0, 0, 1. Just to make sure we got it right, how many values did we have in the first place? We had 30, right? So I'm just doing a quick count. This is 9, 15, 23, 26, 27, and 3 is 30. So 30 total. So you want to do a quick check that you actually included them all in your list. You didn't miss one. I always recommend sort your values and enter them the way I did it. Don't go back to this one and try to sort because then you're going to be all over the place and you might miss one. Or you might put them in the wrong category or interval and then you're in trouble. Okay, so data into the table, into the graph. Okay, so we're going to create a histogram and a frequency polygon at the same time. Let's just go here and down the x-axis, it's always your interval. So this is flow rates. Flow rates in cubic meters per second. If there's anything I can guarantee you next year is if you forget the units, you're going to lose marks. Like that's just a standard for even for pre-cal. You got to label and put the units that go with it. And what would this be here? This is my frequency. What would that be? Anyone? That'd be years, right? Number of years. Number of years that flow rate occurred. Otherwise known as our frequency, right? And then, so because of my table, I'm going to try to have both on there. Notice that my table starts at 0, so then I can actually start right at 0 here. And I'm pretty sure I've made it work out, right? To 1,000, 1,500, 2,000. And if not, we're going to extend our graph. You're the very first group that gets a booklet. So obviously there's some issues here and there with spacing. And I'll have to fix that. 5,000. Right? So notice that I'm just using my interval and I'm going up by that. You don't double them up, right? You just go 0 to 500, to 1,000, to 1,500, and so forth. It's a consistent increase. Y-axis, just look at your frequency here. The highest number is 8. The highest I get to is 8. So let me see here. If I make everything worth 1, 1, 2, 3, 4, 5. Yeah, that'll work. That'll make this 10, and that is good enough. Let me just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it goes up by 5s. Okay. Let me just zoom out a little bit more. I want the whole frequency table on there as I'm working through it because they go hand in hand. Okay, so from 0 to 500, there's 5. So that's a bar that goes right across like that. And I always like to put the frequency on top. And then there's 4 for the next interval. So 4. And then we have 6. I won't always give you a nice grid like this, but I thought for notes it's pretty nice. We don't have to use rulers. And then, because then it looks all crooked, it looks bad. 8. So 6, 7, 8 gets me to there. And then 3. And then 1. And then 2. 0, 0, right? And then the last bracket just has 1. So that's what your histogram looks like. Okay? And let's do our frequency polygon right over top of this. And I'm just going to find the midpoints. There's a midpoint in this category, and a midpoint here, and a midpoint there. And now I can connect them. There I would want you to use a ruler for that one. And it tells us that we need to close that off, right? So we need to go to the x-axis. So this is coming back later on, so you should be comfortable making a frequency table and a frequency polygon. So at the beginning, right? Let's just put it this way. At the beginning, when we looked at the data, you would have to agree it was all messy. Could you, or unless you're a mathematician, right? Or you just like you have an amazing vision for things. But if you were to just give me that right there, Mr. Dirksen, what do you think? Red River flows, like what do you think? Just this. It'd be like, I don't know, right? I don't know. But if you arrange it into categories, like let's have brackets and let's split it into categories and into intervals, and then graph it, you can tell, right, that most of the action happens here. Okay. So when they built the floodway, you were not alive. I wasn't alive when they made the first one, but they underestimated. It wasn't built. It wasn't built to withstand the kind of flooding we actually. So the one they made in the 50s wasn't high enough. So they had to redo the floodway and digging it deeper so that the flow rates that came in could be diverted along the floodway. And so engineers kind of look at this, okay, historically speaking, this is what's happening. And the challenge now with climate change is to see, okay, this is what has been happening. What about climate change? Like, how is it going to actually go exponentially worse? Like, so they might have to build things 2 to 3 times bigger than what historically has been happening. That's one of the challenges right now. Any bridge they build right now, they raise it way up. I don't know if you've noticed like the new overpasses they make or the bridges over rivers, they make them way higher than before because they are kind of expecting the flows to increase. Okay. So basically, data points into this The hardest point about this here is to come up with the interval width. You determine that, okay? So let's say, let me just give you an example. Let's say you take the range and divide it by 10, you get 2. Bang on 2. Use it. Don't round it, just use 2. If you get the range and divide it by 10, you get 23.5. I would probably go 25, right? So this is just to guide you, but you ultimately pick, right? I round it up. I will say that in the notes here. This is a guide, right? I round it to 500, right? And that's how I came up with that. Okay. So the range tells you, okay, this is the spread you're looking at. If you want to divide that up into 10 equal categories, this is what you must do. Okay? Capiche? All right. I want to take it one step. Well, this is basically it for graphing. Like, you must have a frequency table if you want to graph anything. You must have it. You can't do it without. Okay? So don't just try something there. Okay? Let's go over to page 11. So let's switch gears a little bit. So I know I'm overloading you with information, but it's because I know where we're heading and I need you to know a bunch of stuff. That's the problem. So you might feel a little bit overwhelmed. And I'm going to try to make more sense of it as we go through it. Okay. So calculating the mean and standard deviation if you're given a frequency table, right? So not always will you be given data points individually. Sometimes they will already have been arranged into a frequency table. When you're presented with a frequency table, you do not know the value of the individual data points. In such cases, we simply, step 1, calculate the midpoints. Right? I like to highlight things. Calculate the midpoints of all intervals. Step 2, the midpoints go into L1, frequency go into L2. Okay? You're like, wait a minute, L2? Is that like quadratic regressions? Not quite, but you'll see how that works. Step 3, okay? You should see this. Watch. You should see one variable stats L1, comma L2. Note you must enter 2 columns. Okay? You must enter 2 columns. The entries in L2, L2 indicates the number of values in that interval. Okay. So I think I'd like you to have this here. One variable stats L1, comma L2, like that you remember, okay, if it's a frequency table, I need to do the L2 thing, right? I can't just do L1, right? I need to have both 2 columns filled in. Okay. Please find the mean, standard deviation, and range for the salaries of company A. So we're going to do company A first in Canadian dollars. Let's go ahead and find that. I don't know the answer. I have it written down, but I need to type that in as well. So let's go ahead and do that. So clear whatever is in L1 and go ahead and click away. This is also going to show, or I guess show you, do you need to double check when you enter a value? Do you need to take an extra second to type things in a little slower so you don't miss a value. So I'm just going to double check. My last entry is the 16th entry, and I go 4 times 4. I do have 16 salaries, so that's a good sign. Stat calc. I'm going to write this down. One variable stats L1, and I get, this is dollars, right? 3835.25. The standard deviation is $914.22, and the range, let's put the range right next to standard deviation, because remember they go hand in hand. A lot of you were you gave me some pretty good answers with the Ontario having 1,000 as a range. I liked your answers. You were paying attention. Sometimes I feel like I'm talking to myself. All right, so it's 6,500 minus 2,750. It's probably a good habit to write that down, and that is $3,750. That's the range. There's my standard deviation. There's the mean, right? So everything is given there. I will make a note. All salaries are listed individually. Okay, that is a big. Okay, all salaries in this case, they were all individually stated, right? You just typed them all in and you just figured out the mean and the standard deviation. But what if a different company, company B, okay, company B was a bit more proactive. Let's just put down here, what would N have been for this particular company? 16 salaries, right? Or employees. For the first table, that's very obvious to us. So company B was a bit more proactive. They hired perhaps a company that organized it already. This is a frequency table. A frequency table. And you're like, but what about the tally column Mr. Dirksen is missing? Yeah, they're not going to include that because they already figured it out, right? So this is the interval, and this is the frequency. So we can write that down underneath it. Okay, this is the interval, and this is the frequency. Can I change that? Sorry. Some of you are like mumbling. Why would you do that? So this is the frequency. I need that space, that's why. And this is the interval. Okay. So you should, when you look one like that, it's like, okay, that's a frequency table. You should recognize that right off the bat. This is a frequency table. The problem is we don't have all individual salaries listed. So what do you need to do here? You need to figure out the midpoints. So basically, the midpoints between these two would be 2,000 plus 2,500 divided by 2, right? You already know the answer, don't you? But I'm going to do it, hit equals, make sure you hit equals, so it's 2,250. Okay. That's your midpoint. What would be the midpoint between these two? I bet you can figure that out. 2,750, right? If you're not sure, just do what I just did, add them up and then divide it by 2. Then we have 3250, 3750, you should see a pattern, and this is 4250. It's going to get a little messy here, but these are midpoints. Can we highlight that, the midpoints, so that it sticks out? Those are midpoints. It's basically the average between the interval, right? It's that point in the middle. This is what goes into L1. And you take the frequency and you put that into L2. Okay. Can we highlight the L1 and the L2 as well? And so we need one variable stats, L1, comma, L2. And let's figure out those values. So I invite you to do that with me. Go stat, edit, clear whatever was in L1, and you type in the midpoints into L1. And then I type in the frequency into L2. All right. Just to clarify, you should know that this means that there are 2 employees that make between 2,000 and 2,500. There are 5 employees that make between 25, right? So this is the number of employees here in total. So let's do the calculation here. Stat, calc, one variable statistics, and then we call L1, comma, second 2 to call L2. And then we hit enter. Before you write anything down, what is N telling you? There's 25. 2 and 5, 7, 19, 20, 25, right? So there's 25 total. We're going to put N is equal to 25. That's very important. 25 employees. And so this, when you do the calculation like that, it's actually taking into account that you have 25 employees. So we're going to write down our average. Our standard deviation is 467. And our range, call it again. There we go. Our range is just take away the min and the max that you see on your window there. I'm going to circle them. I don't know. I just like them to stand out, right? So when there's a frequency table, watch this. If I just, sorry, I'm going to cover this up for a bit. Let's say you forget this, right? You're writing your quiz or your AC tomorrow, and you just go L1, right? Your average is different, 3250 versus 3210. And how many employees is it now thinking that you're considering? Only 5, because it's saying, well, you entered 5 numbers into L1, so obviously it's only 5 people, right? So the L2 tells the calculator, oh, wait a minute, there's many employees making that average salary, right? So you got to watch out for that, right? This is you got to watch out for that. So don't make that mistake. Calculate the mean, the standard deviation, and the range for the salaries. We already did that. How many employees work for this company, right? N is equal to 25, therefore 25 employees, right? You could have just added that up too if you wanted. Both of them are valid, right? How do the salaries in both companies compare? Explain this using the mean and the standard deviation. So this is where it all really shows how much you understand. And so we could say this. I will do company A. Company A. Let's just write down the average. The average is 38, 35, 25. And the standard deviation is 914.22. Okay. Company B has an average of 3210 and a standard deviation of 467.33. So if you just don't look at the standard deviation, just look at the average, which company appears to be paying more in general? You'd have to say company A, right? But when you look at their standard deviations, which company is more consistent with their salaries? You'd have to say company B is more consistent because it has a lower standard deviation. So, you could say that company, although company A has a higher average, the standard deviation is greater, which means that the salaries are more spread out. So you could actually be potentially making a lot less than the top paying person, right? Because it's kind of spread out. And it's usually outliers. It's usually outliers that give you the wrong perspective, right? For example, if you look at the salary out here, this one is actually an outlier. If you look at most salaries, they're not even close to 6,500, right? Most salaries are 5,000 or less, right? So this outlier is like inflating the average, right? So let's give a statement here, okay? Company A generally pays more, right? Greater average, greater mean. So you're making a reference as to why you're saying that, okay? But is not consistent among employees. Why are you saying that? Because it's a greater standard deviation. Okay. There is a great potential to make a lot less than the mean. Sorry, but I made it. Okay. I'm going to zoom in. You want me to zoom in? I'm going to try my best here. Maybe I'll just read it to you because I wanted to have that. I will read it. Company A generally pays more. Why are you saying that? Because it has a greater mean. But it is not consistent among employees. Why are you saying that? Because there's a greater standard deviation. Please always make reference, like in this problem, it means this because of that, right? This tells me what I just said. This measurement here tells me this, that inconsistency. But there's a great potential to make a lot less than the mean, okay? thinking if I should give you, go ahead, if I should give you a visual. I think I'm just going to leave it because there's going to be chances down the road. I think I'm going to leave it there for now. Can you get your workbooks out, please? I will actually give you some class time. I could plow through it, but I feel like you need a bit of a break. I can sense it. That's okay. We all need a break from time to time. If you back up on in your notes, right? On page 10, you have the pages assigned to you, pages 5 to 8 in the workbook. But I want to kind of highlight the ones I really want you to do, okay? I want you to go to page 5, and I want you to circle question 2. Calculate the mean, median, mode, and it doesn't say standard deviation. Please just do it. If it doesn't say standard deviation, just do it. I used to wait with standard deviation till way at the end, and I realized to just expose that right away because there's the range and the standard deviation just go hand in hand. Okay, and then create a frequency table, draw the corresponding histogram. Right, so you need a frequency table and a histogram. Let me give you a bit of a hint here. Let's decide on, let me just pause this here. Last one, what did I say? 3 inches here, the width on page 7, and 5 minutes on page 8 for that question there. All the keys will be posted. Page 7, just that one question that's on there. And the width that I used was 3 inches. If you want to know how I did it, just look at the key. I tend to use like intervals that would give me a round number. So